So this is 2013 question 1. It was a complex number question on the ordinary leaving cert paper. So first one says to plot Z1 and Z2. Z1 being 3 minus 4i, so 3 on the real axis minus 4 on the imaginary, so that was Z1. Z2 was 1 on the real axis and plus 2i on the imaginary axis. So that's Z2 there. So that's part A. Part B. From the diagram, is it possible to say that Z1 greater than Z2? Now, you have to know what these bars mean. So they are modulus bars, okay? So the modulus means the distance from the origin, okay? So is it fair from the diagram to say that the distance, or the length from here to here, to Z1, is greater than Z2? Well, I think it's clear that it is. So we can say yes. The reason, because Z1 is further from the origin than Z2. Something along those lines. But in part C, you can see that they want you to verify it algebraically. Alright, so we actually have to find the length. We actually have to find the modulus. So the modulus of a complex number, for example, well, a plus bi, would be the square root of a squared plus b squared. So we want to first find the modulus of Z1, which is 3 minus 4i. So the modulus of 3 minus 4i would be the square root of 3 squared plus minus 4 squared. That's our a and our b. So that would be the square root of 9 plus 16, which is the square root of 25, which is 5. And then we will find the modulus of Z2, which is 1 plus 2i. So the modulus is we're going to find the square root of 1 squared, so a squared, which is 1, plus b, which is 2. Now, not the I, just the b. Okay, just the 2. So, square root of 1 squared is 1, and 2 squared is 4. That would be the square root of 5. And is 5 greater than root 5? Well, yes, of course it is. Okay, so therefore, Z1 is greater than, the modulus of Z1 is greater than the modulus of Z2. Prove that. Alright, now, for the last one, Z1 divided by Z2. Let's have a go at this. So Z1 is 3 minus 4i, and Z2 is 1 plus 2i. So if we are asked to divide complex numbers, what we have to do is multiply top and bottom by the conjugate of the bottom. So what is the conjugate of the bottom? Is 1 minus 2i. So you just change the sign of the imaginary part. So we'll say that again. To divide complex numbers, you've got to multiply top and bottom by the conjugate of the bottom of the fraction. So that's what we have here. We're going to multiply them out separately. We have top. We're going to multiply them. So we have 3 minus 4i by 1 minus 2i. I'll do the first one the long way. So let's just break up our brackets. Multiply these out. 3 by 1 is 3 minus 6i minus 4i plus 8i squared. Then what we will do is tidy that up. 3 minus 10i plus 8 by minus 1, which would be 3 minus 10i minus 8, and then we do our reals together, and that would be minus 5 minus 10i. So that's the top of the fraction. I'm going to do the bottom over here. So it's just multiplying. It's not hard, it's just, it is quite a long question. So 1 minus 2i. I'm just going to multiply this the quicker method. 1 by 1 is 1. 1 by minus 2i is minus 2i. Just to show you a different way of doing it. And 2i by minus 2i is minus 4i squared. So i's together. Minus 2i plus 2i, that's 0. We have 1 minus 4i squared. I should, instead of I squared, remember you sub in minus 1. And we're going to get 1 plus 4, which is 5. So let's put our answers together. I've kind of run out of spaces here, but let's put our answer here. And the top of the fraction, alright, so we're going down here, was minus 5 minus 10i over the bottom, which was 5. And this simplifies down. 5 goes into everything, and we will get minus 1 minus 2i. And we are done.